Okay, we're back, and I'm ready to show you how to use the TVM Solver on these finance questions. And I'm going to do I'm going to do 5 different problems. I'll do 3 from the annuity savings section, and then I'll do a problem for the annuity payout where you're getting money back, and also a loan repayment. And it really won't take very long, as you'll see. So you may recall that we had 3 problems under the annuity savings plan section in the memory organizer layout, and I'm going to do all 3 of these. So you'll remember that the first example that I would have had on a note card for preparing for the quiz would be to find the total value after making regular deposits. And so as you read through this, it says if you deposit $200 per month in an account earning 4.5% APR for 30 years, what will be the value of your investment? Assume the compounding is done as often as the deposits, and that's what we always will assume on these. It means if it's deposit every month, then the compoundings are 12 times a year. So our total value of our investment, this P is unknown. We have 200 for the payments, 4.5% for the rate, and K is equal to 12 and N is equal to 30. So I want to talk about the TVM Solver, and I'll show you that. We'll open that up. It'll always have 3 or there's 7 places to fill in there, and this first one N is the total number of deposits that you'll make. I %, that'll be your interest rate, and then the PV is the present value. Then you'll have your payment, then you'll have your future value, and then they ask you to write in, this is payments per year and compoundings per year, and these always have to agree. They always have to be the same. So let's take a look at this. The number of deposits, you're making them every month for 30 years. So that's 12 times a year for 30 years, which is 360. Your interest rate is 4.5%, and on the TVM Solver, you just put in 4.5. You don't change that to the decimal version. It's 4.5%, so you just put in 4.5. The present value of your investment is what you start out with, and when you're investing at the beginning, you don't have any money, and then you're going to make $200 deposits every month, and the future value, that is what we do not know. Okay, so let's get out that TVM Solver, and so I'm going to pop that up, and we'll take a look at what that's going to be. Now we already had N was already equal to, now I'm going to have to go over to the calculator here, and how did I get to that solver? Let's just back up a little bit. I'm going to go over, I'm over in this area, I'm over here trying to see over here where it says apps. So the first thing I'm going to do is I'm going to click on apps, and then finance is number 1, so I'm going to select enter. It's already had it. I want finance apps, so I'll hit enter. We're always going to use the TVM Solver, so I'll hit enter for that. And now for N, remember that was 12 times 30. Now you could actually put in 12 times 30 if you wanted, and it'll calculate it for you, and then you hit enter. The interest rate was 4.5%, and unlike the formula, we don't make it 0.045, we just use 4.5. The present value, since it was investment, remember that was 0. The payment was $200 a month. Oops, that was supposed to be I didn't hit enter on the 0 there, so I have to back that up. that should be, delete that, that should be 0 there, and hit enter. I didn't hit enter. 0, enter. And now the payment should be $200. Now, let's talk about that. In the problem solver, you hit the negative sign because you're putting out, you're losing. Basically, you're giving away $200 a month, so you're putting that out. Your future value to be positive, you have to be putting money away. And so our future value is unknown. So, by the way, I have to enter. The future value is unknown. Now, I can have any number in there I want. It doesn't matter. I can put in $9.99, or I can clear that and just put a 0. I have to have something in that entry. It's whatever number it is. It can't be blank. Now, it's monthly, so that's 12 payments a year, and we compound always the same. If this was annual, then we put a 1 here instead of a 12, but this is monthly. So the future value, I can put that as 1. And by the way, I want to go up, and I got to use my up arrow. Notice I'm over here on the calculator. I got to click the up arrow to highlight this. Now, how do I calculate this? I want to know the future value. So that's where I go over to the calculator here. I'm going to click on alpha and then enter. And that will tell me what the value of that investment will be, which will be $151,877 and about 23 cents. So that's the future value if you put away $200 a month at 4.5%, 12 times a year for 30 years. Pretty simple. And to show your work, you just jot down this is what you'd put in for your work. This is all you had to enter into the calculator. So let's take a look at the next problem, and let's see. Let's go to the next page. This one was finding the payments needed to reach an investment goal. Now this is very similar to the previous problem. It's still using the same formula if you were using the formula method. However, this one you want $1 million, so here was when the million was needed at the end. So now we go back, and I'll jot down what do we need here. Well, we need to know the number of compoundings. We need to know the interest rate. We need to know what the present value is on this investment, which is 0 always when you're investing something. If you're just starting, of course, how much you're putting in, then the future value, and then of course the payments per year and the compoundings per year. And in this problem, as you can see, you want to have an account value of $1 million, so that's what we want. We want $1 million in the future. So that is going to be $1 million. And we the number of compoundings. Now, how many years do we have to do it? It said 40 years. So that should be 12 times a year. I think this said monthly. Didn't it say monthly payments? Yeah, we want to have, what would be your monthly payments be? So we got to have monthly payments. So it's 12 times 40. And your interest rate was 6.25%. Oops. Let me erase that 5. 6.25%. And our present value, we don't start out with anything in this case. And our payment, that's what we do not know. So we can put any number in there that we want. You know, not a variable, just some number. And again, we're doing monthly. This is monthly payments. So this is 12 again in each of those places. So let's go to that solver and see this time. Again, I'll start over. I'll go back. I'll clear this. Now, to get out of this, there's a quit button up here on the upper left. Notice I'm over here. There's a quit button up here. So I go second quit. It's second mode, and that'll clear it. And this is what you get at this is your screen. So I'm going to hit, remember again, I'm going to go down to apps. It's this value right here, apps. And then finance is number 1, so that's already selected. I hit enter, enter, and I'm right where I need to be. Now this one was 40 times 12, which you can just put in 480 if you want to, or you can just go, you can enter the 12 times 40, if you know what that's 480, and then the next, so you hit enter, and then this is 6.25. We can type right over the top of this. You don't really have to clear it if you got enough numbers to cover the ones you had. And we'll hit enter. Our present value. You can also hit down arrow. You can up and down arrow along this. Your payment, now in this case we said the payment was going to be, what was that, $600. Let's look at that again. What was that payment going to be? It was going to be, oh, that was what we didn't know. We're trying to get to the $1 million. So we don't know what our payment is. That is again unknown. So I'm just going to put 0 there. Zeros if you want. The future value though we do know. Now I can hit the down arrow. That we want $1 million. So that we got 1,000,000, 1 million. Again, it's monthly, so those are going to be 12s. And now, what do we want to know? We wanted to know the payment. So we go up to the payment. That has to be the highlighted value. Then we hit alpha, the green button over here, alpha, and then enter. That means that's solve there. And there it is. And that means you have to put out $469.06 a month. It's pretty simple just to use that. And again, you'd put all those numbers for your work. This is how you'd show your work. You'd put all those numbers in exactly as you see them there to show that that's how you did the problem. Now let's go back to the next page. And this is find the number of years needed to reach an investment goal. Now let's go ahead and we want 15. Now this one we want $15,000. We have payments of $600 at 5%, and we want to know n, the number of years. So 15,600. So on that one we get n. We do not know n. We know it's 12 times something. That's what we're looking for. We're really looking for that n. So we don't know this number. This is the question mark, really, right? And so the interest rate we already knew is 5%. The present value, this is again an investment, so that's going to be a 0. The payment we said was going to be $600, and the future value was going to be $15,000. We want to know how long it would take to save $15,000 if we were putting away $600 a month. And again, that's 12 times a year. These are supposed to be monthly payments again. So let's make sure we keep that down. Our n is 12 times the number of years, which we don't know, our capital N. So that's 5. I'm just jotting down those numbers so I don't forget them. And now I'm going to go back to the TVM Solver. I'm going to leave those numbers. You can just type right over the top of them. So n is our unknown, right? We don't know what that is, so I'm just going to put zeros there. And then down arrow. Or that, now I have to delete those because those are, so I can hit clear, or I could delete. That was 5%. Our present value is 0. We were going to make $600 a month investments. And our future value, we wanted that to be, $600. $600 a month. And we wanted that to be $15,000. I'll go ahead and hit clear for that. And that we want $15,000. And it's 12 and 12. So now, and this is, I want to go up arrow. That's what I want to know. So I'm going to go over and hit alpha, solve. For that, I'm over on the screen. That's going to take, what's wrong? Why is that a negative? I did this wrong because I should have down here, remember, I'm putting out $600 a month. So that should be a negative 600. So I can hit second insert, negative 600. Then I'll go back up and I'll hit alpha, solve. And there you go. It's 23.8 payments. That's the total number of payments. Now remember, that is 23.83 is 12 times n. 12 times n. So if we go back to the problem, our 12n turned out to be 23.8 something. If we divide both sides by 12, that means it's going to take a little less than, I'm going to just say approximately, that's almost 24. It's about 2 years. It'll take a little less than 2 years to save $15,000 if you put away $600 per month. Okay, let's go to the next page. Now this is an annuity that we're going to get money from, finding how much is needed to provide a regular income from an annuity. Now if you were to do this on the using the formula, you have to use a different formula. On annuities where you're getting money out of them, then you have this 1 minus. You have to make sure that 1 comes first, 1 minus the formula 1 plus 0.04 over 12 to the negative 12 times 25 power. So notice you get the 1 minus instead of this minus 1 at the end, and that's a negative exponent. So be careful if you're using this formula. Now if you're using the TVM problem solver, it's very simple. But again, before we do that, we need to make sure we write the values down there. We have n, we have the I percent, we have the present value, we have the payment, or the withdrawal. Actually, withdrawal. They always call it payment, but it's either payment or withdrawal. And then we have the future value, and then we have the payments per year and compoundings per year, which always are the same. So, what is our n? How many payments are we going to make? Well, we want to, how much would be needed in an annuity if the account was to provide $6,000 monthly, a $6,000 monthly income for 25 years at 4% APR. So this is how much would be needed in an annuity. So we want to know how this big lump sum at the beginning, because we're going to be taking money out month after month. So what is that going to take? Our n is going to be the number of compoundings. We're doing it for 25 years. So that's 12 times a year for 25 years. That's 300 if you want to just put in 300. The percent, your 4% is your interest rate. Your present value, that's what we don't know. We don't know how much we have at the beginning, so we can just put a 0 there. The payments, well, we want those to be $6,000 towards us. We want to be getting $6,000. And our future value, we're going to spend all that money. So with these, the future value is 0. Okay? We're going to be using all the savings that we had, so we won't have anything at the end. And these, it said, were monthly income, so these are both going to be 12s. And we're going to be, now this is something else. Since this money is ours to begin with, we're going to be taking it out, so we'll need to put a negative in there for the 6,000 on that one also. So let's go ahead and look at our TVM solver again. Same solver. Now remember, and this was, we had 12 times 25, that was 300. So I'll put in 300. Our interest rate, so we'll enter or just down arrow, either one. Enter or down arrow will get you to the next place. And then we get 4. Enter. The present value we do not know. So remember, that's unknown. The payment, now those are, we're supposed to be taking out $6,000 a month, so that's going to be negative 6,123 on this one. We're going to be removing it from our account and giving it to ourselves actually, but we're still taking out. And the future value, we want that to be 0. Now this says 0, but we know it's not this 0. We could put any number up here if we wanted. You could put in 1,000 if you wanted, or whatever number you want, because we're going to highlight that, and we're going to now hit alpha solve, and it'll change it to the proper number, which is, look at that, $1,136,714.90. So you need over $1.1 million. That would be your answer right there. Yeah, that's how you would, sure, that's how you would, there's your answer. 1.136, 1,136,000. We could put a comma there, a comma there. I'm going to get that flasher away from that, so I'm going to go down. So anyway, that's how we would take care of that. Okay, so let's go to the next problem. The last one. Finding the monthly payments on a loan. What will be the monthly payments on a $120,000 loan that's going to be repaid in 30 years at 3.5% APR? Now, this is the same formula. A loan formula and the annuity formula are the same. So check this out. You've got the minus there, 1 minus again if you're using this long formula, and don't forget the negative in the exponent. That's very common that people forget that. So let's again write down what we've got here. It's a monthly payment, but we've got a $120,000 loan. That's the total amount that we start with. That's the initial value. We want to pay that off down to 0, and we get 30 years to do it at 3.5%. So again, let's write N is the number of payments we're going to make, and that's 12 times 30. I percent, that was 3.5%. The next one is our present value. Now this is a loan, so we owe money to begin with, and that's $120,000 that we owe. And what's our payment going to be? That's really what we want to know. We don't know that. So we can't leave these blank, by the way. They don't allow a blank to be used. They won't let you on the calculator. You can't leave a blank. You got to put some number in there. And then the future value of that loan we want to be 0. So this is going to tell us this answer is going to be a negative in here because you're going to have to pay that money out. And now, and these are going to be, again, these are going to be monthly. These are payments per year and compounding per year. These were all monthly. Almost all the problems we do are monthly there. And so let's go to our solver. Let's we'll clear all that. I'm going to go out and actually, let's see. I need to get rid of that. That has to be my cursor again. So there we go. Now I got my cursor back. Okay, so we have to come up here, and now remember, I'll go up arrow. That was really supposed to be 12 times 30. You can just write 360 in there. 360, enter. The interest was 3.5% on that. The present value of the loan was $120,000. I'm going to go ahead and clear that because I don't know if that'll cover it. The payments, that's what we didn't know. I'll leave the negative 6,000 there. You can put a 0. The future value is going to be 0, and we're going to do this annually. So we're right where we need to be. We want to find out what the payments would be on that loan. So we just hit alpha, solve. And there it is, $538.85 a month. That's your answer right there. Okay, so that concludes this video.